CATIA V5, how to convert STL files into solid objects. So this will be a follow-up for one of my most viewed video. So we see this was posted almost 5 years ago. And I received the following comment today: what is the best way to connect the surfaces and create a solid? So I have over here opened the same file. So after we imported the STL file and save that as a CAD model, we will have multiple surfaces over here, and all that we have to do is to join those. So as you can see over here, I have the join. Within that join, I have added all the surfaces that import the STL files. In this case, for the Egyptian cat figurine, there were a total of 115 surfaces. You can leave the check connectivity and check manifold. You can also enable the merging distance, but usually if the STL doesn't have any gaps, this will automatically join. So in this case, I will just click cancel since I already have that defined. Be aware that joining those surfaces will take some processing time. As we can see over here, I only enter that feature to visualize it, and afterwards I cancel it, and CATIA waited a little bit for that. And after that, you will obtain a join surface. So this will be the join surface. If I will swap the visibility over here and I want to see this shading with edges, we're going to see the triangulated mesh that will define that model. If you don't want to see those edges, this will be the actual mesh behind that. And all we have to do afterwards is just use the closed surface feature. So this will be available within part design and also within Geometry design. And all you have to do is do the closed surface. You will select the resulting join surface over here. You're going to click OK. It will take a little bit of processing time, and afterwards you will obtain the solid body for this. Currently, since I have my settings set to create individual geometrical sets, the closed body in my case was added over here within the part body. Therefore, if I will just hide this join, because they are currently overlapped, if I will hide this, underneath that we're gonna have that surface. So this actually hidden the closed surface, so I will go within the geometrical set, scroll down all the way, hide the join, sorry. And underneath this, we're gonna have the solid surface. Since this is a solid surface, we can start working with part design. That also means we can, for example, I can go within a section like this, and we're gonna see that we're gonna have material added over there. And this will be compatible with part design. So that means I can go over here, I can create a new sketch. In this case, the STL wasn't aligned, so you can check my videos regarding various tips and tricks about CATIA in order to see how to center that. Because a 3D model has been added and not aligned initially. But we're gonna see that now I can use this to either do a cut or an extrude. In this case, I added an extrude. But also notice that since this has a complex surface, everything will process a little bit slower. Now, depending on your computer, currently my computer is almost 11 years old, so this is quite old and not that recommended for heavy processing. But that doesn't mean it will not work. It will just take a little bit of time to process. Now, this will do an extrude, and since the extrude will automatically be extrude upwards by default, it will also have a little bit of overlap with the existing geometry that is already solid body, and this is why CATIA takes a little bit of time to process that. Another approach is to use the other workflow that I also presented within my older video, and that makes use of the quick surface reconstruction, but that is a different workbench and is not that widely available So the first workflow that uses demo optimizer and part design is mostly available for the vast majority of CAD users. But you can also take a look at the automatic surface approach. This again will take some processing time. We're going to see how that will be defined. You can add a mean deviation. In this case, I added 0.1. The surface detail 5000. You can also check full internal tangency, but that will take a little bit more processing and will change the wireframe of the model. But afterwards, with this, you're going to do the same. So you're going to apply that closed body onto this resulting surface, and you can work with that as well. Over here within the video, I didn't do that, but I have other videos regarding that. I only did a deviation analysis between the original STL and the newly automatic surface. And we're going to see that the deviation analysis will look like this. So the vast majority will be in green. That means that the deviations are between 0 and 0.07 or minus 0.28. But there are some areas, for example, over here on the neck, that will be all the way up to 0.23 millimeters. So this will still load. For some reason, this is processing quite slow. This is why I usually recommend the other solution that makes use. Okay, so we have this. And the pad automatically went like this. So this will be the overlap. If I will click OK, let's see what will happen. We see that the extrude will have an update. It usually should represent this visually as a field area, but since that was overlapped over there, it has this weird visualization, especially like reverse extrude. It will actually do a cut. But I'm really curious because I didn't notice this, because I usually don't follow this workflow when I'm working with STLs. I'm following the workflow that makes use of automatic surface, and that will process a lot better. So let's see how this extrude will go. Maybe I will fast forward the video over here so that it won't take so long. So I will cut it over here, and we're gonna see the final result at the end of the video in the post-processing. And we have the extrude added over here. And again, this took a little bit of time. I will also do a cut so that we can see that this will also work with a cut. So I will delete the pad. I don't want to delete the aggregate elements. And using the same sketch, now I will do a cut, and that will trim the cat figurine over here. So let's see how this will process with a cut, because the extrude took quite a little bit, so I did that within post-processing. I will reverse this on a distance of 20 millimeters. And we see that even when I click the reverse direction, this takes a little bit of time. Initially, the direction for the cut went downwards, and that previewed really fast since the mesh wasn't overlapping over there. But now, since this will be overlapped over here, this will take some processing. And this is why this workflow is, again, not the best solution, and I highly recommend to use the automatic surface. But again, that requires an additional workbench that is not widely available. So other solutions would be to make use of either Fusion 360 or Blender. And within the near future, I will create some videos regarding this, because Blender has some of the best tools to work with STL files. And they are a lot more powerful than some CAD solutions like CATIA and Fusion. And consider that the software is open source. I think that that's quite impressive. Okay, so I will trim the video over here, and we're gonna see within the post-processing this extrude cut. Okay, and we have the extrude process over here. Now, on the video I've trimmed this and it didn't took a lot to process, but I recommend that in this case it would be recommended to take this closed surface and have it copied and paste special as a result within a new part and work over there with that, because then it will not take so much time to process, because over here this closed surface is linked to the join and the other surface, and that will heavily increase the processing time over here. Okay, so I hope you enjoyed this kind of content. I will position a similar video over here on the left side and the subscribe button to the right, so also consider to leave me a comment because that really helps. So that's it. Thanks for watching.